Hi students, we'll be discussing some JE advanced questions from the topic loss of motion. From this chapter, you can expect 2 to 3 questions for your JE exam. And we have a question here. In this question, a lift is accelerating upward with an acceleration 6 meter per second square. A person is standing inside the lift is standing above a weighing machine which is kept at a 60-degree incline. We need to find the reading of weighing machine. First of all, this question is from a question of non-inertial frame. The lift is accelerating, that's why it's a non-inertial frame. You cannot directly apply Newton's laws of motion in a non-inertial frame. If you want to apply Newton's laws of motion in a non-inertial frame, you have to define a pseudo acceleration. I'm taking all the mass as M, the person standing above the weighing machine, and I need to define a pseudo acceleration such a way that it is opposite to the direction of the acceleration of the frame and the same value. If that acceleration of the frame is A, I have to define A in opposite direction. And we'll be having acceleration due to gravity G would be the downward. Okay. Then we'll be having reaction force. You can say Rn. That's always perpendicular to the surface. And the angle with the horizontal, it is given as 60-degree. Then this angle also should be 60 degrees since we are constructing two perpendicular to the angle construct. And we need to find the reading of weighing machine. Reading of the weighing machine is nothing but the reaction force. Once you find the reaction force, that would be the reading of weighing machine. For finding reaction force, we can resolve the force perpendicular to the surface. Okay, we have Rn upward to the surface, and we have G and A, that acceleration, then M into A plus G downward, but we need to get a component along this plane. This plane we need to get up. Then the force would be equal to mass into the acceleration. Both acceleration you can add up since it is on the same direction. You can just add it up. Then we have to take the component along the vertical plane to the surface, that is cos 60. It should be 0. Then Rn should be equal to M into G plus A cos 60. You can substitute the value. M is given as 50. G plus A, G we can take it as 10. Then A is 16. And cos 60 is half, which is 400 Newton. Option C. We have another question here. In this question, a pulley string system is there inside a car. The car is moving forward with the acceleration A. Means the car is moving towards right with an acceleration A. And the person is standing inside the car. That person is pulling the string down with an acceleration A. We need to find the tension in the string. That's what the question. And suppose we have a mass M here. Is inclined some angle theta because of the forward acceleration. And person is pulling down with an acceleration A. And this angle is given as theta. Here also we have to take the pseudo acceleration like we did in the previous question. Since the car is moving forward with an acceleration A, we can take a pseudo acceleration towards left. The car is moving towards right, then pseudo acceleration we can take towards left. And G would be the downward. The resultant of these two you can use Pythagoras theorem, and the angle would be same. The resultant will come along this line. The angle would be same. You can find tan inverse of A by, this is A, A by G. Then you'll be getting same theta. Okay. Then the resultant would be equal to root of A square plus G square. That is the resultant of these two acceleration. Now you can use Newton's second laws of motion. Net force is equal to mass into acceleration. And we having a tension P, and this is accelerating with A in upward direction. Since the person is pulling with the acceleration A downward from the other side, then the string will be moving upward with an acceleration A. And net force would be tension as upward minus M into the resultant acceleration, that is A square plus G square, should be equal to MA, mass into acceleration of the body. Then tension should be equal to the root of A square plus G square plus MA. That's the option C again. We have another question here. In this question, two bodies are there. Body A having a mass M, body B having a mass 2M. In between A and B, there is friction. The coefficient of friction is mu. In between the surface and B, there is no friction. And we have to find a relation connecting the angle theta and the friction such that A shouldn't slip over B. In that condition, we need to find a relation connecting theta and mu. Okay. It is from this question, it is understood there is no friction between B and the incline. Then B would be moving in this direction with an acceleration G sine theta. G sine theta acceleration, it would be moving down. Since there is no friction, nothing is there to resist that motion, and then G sine theta would be the acceleration down to the plane. Now, for solving this question, we can take the body A alone. Well, taking the body A alone, as we are doing the previous question, we have to define a pseudo acceleration that is opposite to the acceleration of the frame. Acceleration of the frame is G sine theta. It should be having the same value G sine theta, but opposite direction, then theta angle incline upward direction. We have to draw the pseudo force. And we'll be having a reaction force on this. Then frictional force would be there. The frictional force direction, we can just think of. If at all this body goes to slip, it would be slipping towards right, because the body B is moving downward with an acceleration downward. That means towards left it is moving. Because of the inertia, the body would be slipping towards right. Then the force of friction would be towards left. You can say the force of friction is towards left, that we can write mu into Rn. Then the weight of the body would be there downward. That is mg. Okay. Now you can resolve the force in horizontal direction, and you can write the frictional force mu into Rn. Now it is in equilibrium condition. You can apply the equilibrium since we define a pseudo acceleration opposite to the acceleration of the frame. Now you can use the equilibrium condition and you can apply it for the equilibrium condition. Then mu Rn should be equal to the component of horizontal component of G sine theta. We have G sine theta here. We need to get the horizontal component of G sine theta. That is this particular component. That would be equal to G sine theta is the force and its component along the horizontal. Then it's cos theta component. Okay, G sine theta, cos theta. Then for getting Rn, we can resolve the component in vertical plane. Vertical plane, we have Rn is there upward. Then we have a component of g sine theta. We'll be having a component here in this plane. This is the component of g sine theta in the vertical plane. And we'll be having g mg sine theta. G sine theta is just the acceleration. Here also we have to write m. In order to make force, you have to multiply with the mass. Mg sine theta is the force. Its component in the vertical plane. Then it's a sine component. Mg sine theta and sine theta would be equal to mg. Then we can say Rn should be equal to mg minus mg sine square theta. We can take mg common from this function. 1 minus sine square theta would be there. That is cos square theta. Mg cos square theta would be Rn. From this relation, if it's not want to slip, the frictional force mu Rn we can substitute as mg. In this equation, we are substituting Rn as mg cos square theta. It should be greater than the horizontal force. Be equal to mg sine theta cos theta. Out of this, you can cancel mg and mg together. Then a cos theta and one cos theta from the cos square theta. Then you'll be having mu cos theta is greater than or equal to sine theta. That is mu greater than or equal to tan theta. In this we can write it as theta is less than or equal to tan inverse of mu, which is option B. Here we have another question. In this question, the person want to pull a weight W through a height H. Okay. And we need to find the least time he can do that process using a rope. Okay. A person need to pull a weight W through a height H using a rope. And we need to find the least time which can be done. Also, it has given that the maximum tension that rope can bear is N into W, N times of W. Then in this question, first we can deal the tension part. We can, okay, I'll give a rough sketch of this. A person need to pull a body upward. Okay, then tension would be there. Mass of the body is M. Okay, you need to pull it upward. And now we can resolve the force. Anyway, the person has to pull this body with an acceleration. Some acceleration he need to pull. Some the body is at rest, you need to pull it. Then a certain acceleration, you need to pull it. And we can write Newton's second laws of motion, tension, and the weight of the body would be there. Mg downward minus the weight would be equal to m into alpha. Again, we know tension is given as Nw. Nw minus mg equal to m alpha. And we know the W is equal to mg, that you can write n into mg minus g equal to m alpha. From here, we'll get alpha as n minus 1, g m, all the m you can cancel. Alpha as n minus. So we can draw a velocity time diagram for this question. It just travel a total time of t. Initially, it is starting from rest or with an acceleration alpha. a certain time it will do that. Then it has to decelerate. While it is reaching on the top, the velocity should be zero. By using a rope, we cannot reduce the velocity. We cannot decelerate anybody using a rope. If it is a solid, some bar and all, you can give some deceleration on that. But it is a rope, it's a flexible thing. We cannot give any deceleration on that. Then the deceleration has to be taken care by the gravity. Then deceleration we can have with g. That's the maximum deceleration is possible for the g. Then this period it would be accelerating with alpha, and next period it would be decelerating with g. And we can say the first period as t1 and second period as t2. Then as we know, the area under velocity time graph will give the displacement. The displacement here is h. That's what we are lifting. Then the area of velocity time graph would be half into t into v. That's the area of velocity time graph. Then area of the velocity time graph, we can just split into two triangles and we can find the area. In order to accommodate this t1 and t2 in the equation, we can write it as half into t1 plus t2 multiplied by v. Again, we know alpha we can write as v over t1. It is starting from 0. That's why we can write alpha as v over t1 and g as v over t2. It is going to 0 from velocity v. Then g also we can write v over t2. Then t1 and t2 you can replace with v by alpha and v by g. V over alpha instead of t1 and v over g instead of t2 and v. And this equation became h equal to half v square 1 over alpha plus 1 over g. Again, you can replace this v square with something with a t. Means that we have to get the answer of time. Okay, then from here we can write, from this equation we can write v equal to 2h over t. That you can substitute over here. We have h is equal to half v square 1 over alpha plus 1 over g. Then we got v as 2h over t. That you can substitute here, half into 1 over alpha plus 1 over g. We'll be getting there is an h here. Would be 2h t square. You can take the other side. 1h from the square of h you can cancel, and 4 will be there. 4.5 you can get cancelled. You'll be having 2h here. 1 over alpha plus 1 over g, that you can cross multiply. Or else you can write the value of alpha. We already know that. That is written over here. Alpha is equal to n minus 1 g. 1 by n minus 1 of g plus to cross multiply, we'll be having ng here, ng minus g here in the first function, and a plus g. Then you'll be having a 2h ng and n minus 1 g square. That is the value of t square. Then t should be equal to root of 2h ng over n minus 1. G square, 1G and this square will cancel. We'll be having this value. Okay. Thank you. That's all for the day.